Hello students, welcome back in the next class of the polynomials. I hope you have seen the previous videos also, where we have discussed what are polynomials, what are the types of polynomials, and also we have studied the graphical representation of three types of polynomial, right? First was constant polynomial, second was a linear polynomial, and third one was a quadratic polynomial, right? Now in this session we are going to learn the relationship between the coefficients and the zeros of the polynomial. Okay, so on this topic basically you will see there will be questions that are asked in your board examinations, right? So in this type basically we are going to study two important types of polynomials. One will be quadratic polynomial and the second one will be a cubic polynomial. Okay, to start with the topic, what we'll do, we'll start writing the formulas of both the polynomials at the same time, so that it will be easy for you to do the comparative study. Okay, so whenever I say about a quadratic polynomial, what is the standard form of a quadratic polynomial? We can say p of x is equal to ax square plus bx plus c, right? And for a cubic polynomial we can say the standard form is p of x is equal to ax cube plus bx square plus cx plus d. Also one more thing we have to write to keep this quadratic polynomial alive. Alive means to keep its degree 2, what we can say, the coefficient of x square, that is a, it cannot be 0. Similarly, to keep a cubic polynomial alive, again the coefficient of x cube, that is a, it cannot be equal to 0. Now the second point, how many zeros this quadratic polynomial will have? Obviously it will have two zeros. We have discussed what is fundamental theorem of algebra, which says that the number of zeros should be equal to the degree of the polynomial. So let us say this polynomial is having two zeros, one is alpha and the second one is beta. Similarly, this polynomial, that is a cubic polynomial, will have three zeros, one will be alpha, other will be beta, next will be gamma. Now the first formula that you can see for a quadratic polynomial is the sum of the zeros. So what is sum of the zeros? Basically two zeros are alpha and beta and their sum will be plus, so we can say it is alpha plus beta, and this sum of zeros is always equal to minus b upon a. So what is this a and b? Basically a and b are the coefficients that you are going to collect from the given polynomial. As you can see, the given polynomial is ax square plus bx plus c. So what is a? Basically it is a coefficient of x square. What is b? Basically it is a coefficient of x, and c is our constant term, right? And the second formula is called as product of zeros. Product of zeros means multiplication, so we can say it is alpha into beta, and that is equal to c by a. Now same set of formulas we are going to see in a cubic polynomial also, and at the same time there will be one more extra formula. Now let us see which are those three formulas. Okay, the first one will be same, that is sum of the zeros. So we can say here sum of the zeros, that will be equal to, since there are three zeros, we can say it is alpha plus beta plus gamma, and again the formula also remains same, that is minus b by a, correct? So it is minus b by a. Now second formula, here we have written product of zeros, but here we have three zeros, so if I want to take product of any two zeros, I can make three different combinations, yes or no? So one combination can be alpha into beta, second combination can be beta into gamma, and the third combination can be alpha into gamma. So these three products we are going to basically add it, right? So one product is alpha into beta plus we can say beta into gamma, plus the last one will be alpha into gamma. So once again the formula remains same. Here it was c by a, so here also it will be c upon a. And the additional formula, that is point number 3, which says that product of zeros here, product of zeros, it means product of all three zeros, that will be alpha into beta into gamma. This is given by minus d upon a. So once again, what are these a, b, c and d? These are the coefficients that we are going to take from the given standard polynomials, right? So like a will be the coefficient of x cube, b will be the coefficient of x square, c will be the coefficient of x, and d will be my constant. Okay, so these are the set of formulas that we need to by heart first. Okay, after that only we can start solving the questions that are based on this topic. Okay, so let us see now some easy topics that were asked in the previous board examinations. So let us start with the example number 1. So in example number 1, what is given? Find the zeros of the quadratic polynomial. x square plus 7x plus 10 and verify the relationship between the zeros and the coefficients. Okay, so this type of question is expected for 2 marks, okay, in your board examination. Now here there are two tasks that is asked in the questions, right? There are two questions basically which are asked here. First question is, first you have to find the zeros of the quadratic polynomial, which is a quadratic polynomial, right? Degree is 2, so we'll get two different zeros, and after that we have to verify the relationship that we have seen before. It means alpha plus beta, is it minus b by a, and alpha beta, is it c by a. Okay, so if we are getting LHS is equal to RHS, we'll say the relationship is verified. So what is a given quadratic polynomial? We can say p of x is equal to x square plus 7x plus 10. Now factorization of polynomials is something that we are learning from grade 8, correct? So what is the first step of quadratic? We can say the first term into last term, correct? The coefficient of first into the last constant, along with the signs we have to multiply. So coefficient of x square is positive 1 and the last constant is positive 10. So 1 into 10 will give me 10, correct? After that, in factorization, what you will do? You will find two numbers where the product will be positive 10 and the sum or the difference will give you the middle term. So who is the middle term here? 7, correct? And what is the sign of the middle term? It is positive, right? So what we can see here? Can I say 5 and 2? 5 into 2 will give me 10, correct? And 5 plus 2 will be equal to 7. So here in this case, basically the middle sign goes to the bigger number. So if 5 is bigger, obviously it will get positive sign. And the remaining term you have to check above. If you need the product positive, I have to keep the other term positive only, because if I write negative here, plus into minus will give me minus, right? So what is the next step now? Splitting the middle term. So p of x can be written as x square plus 5x plus 2x plus 10. After that, what we do? We start pairing. So this is my first pair and this is my second pair. What is the common between first pair? X is common. So remaining part is x plus 5, and from the second pair, the sign that is written here, we always take that sign as common, okay? So 2 will be common once again, and same bracket you have to copy here, that is x plus 5, correct? So 2 into x will give me 2x again, and 2 5s are 10. Now what is the next step? Same bracket, write it once, x plus 5, and the remaining bracket will be x plus 2, correct? So p of x. Now we are supposed to find the zeros. So what do you mean by zeros? Those values of x, if I keep it here, answer I should get it as zeros, right? It means I have to evaluate or I have to equate this brackets to 0. So if I say x plus 5 is equal to 0, it means value of x has to be minus 5. And similarly, if I say x plus 2 is equal to 0, it implies value of x has to be minus 2. So these are the two zeros, that is minus 5 and minus 2. If I keep it in the quadratic polynomial, obviously the value will be equal to 0, right? So if I say these are my zeros, can I say the first value will represent alpha and the second value will represent beta, correct? Now the first part of the question is over. Find the zeros. So what are my zeros? Alpha is equal to minus 5 and beta is equal to minus 2, right? Now the second part of the question is asking you to verify the relationship between zeros and polynomials, right? So here we have to check two formulas. One is alpha plus beta and second is alpha into beta. And it also says that it is equal to minus b by a and c by a. It means you need to find the values of a, b and c first. And from where we'll get the values of a, b and c? Directly compare the given polynomial with the standard form. So if I compare x square plus 7x plus 10 with ax square plus bx plus c, correct? Can I say here a is a coefficient of x square? So here coefficient of x square, nothing is there, so we can say it is 1. So value of a will be 1. Value of b will be 7, that is coefficient of x, and the constant positive, that is equal to 10, correct? Also with that we have alpha is equal to minus 5 and beta is equal to minus 2. Now let us check the first relation, which says that alpha plus beta should be minus b by a, and after that we'll go for the second relation, which says that alpha into beta is equal to c by a, correct? So if I take the LHS here, what is LHS? Alpha plus beta. What is the value of alpha here? Minus 5 plus value of beta is minus 2. So what is minus 5 minus 2? Is it equal to minus 7, right? And the RHS says that it is equal to minus b by a. So minus as it is. What is the value of b? Value of b is 7. divided by a, value of a is 1. So this will give you again minus 7 only. It means the value of LHS and RHS is equal. So if LHS and RHS is equal, we can say the relationship is verified. So same thing we are going to do for the second formula also, where it says that the LHS is equal to alpha into beta, correct? And what is alpha here? Minus 5. What is beta? Minus 2. So can I say minus 5 into minus 2 will give me plus 10. And now if I check the RHS, RHS gives me C by A. And what is the value of C here? Value of C is 10 and value of A is 1. So that is automatically is equal to 10 only. So again we are getting the same values, and here we can say LHS is equal to RHS once again, and the second relationship is also verified. Okay, so I guess it is a very easy example, right? Only step by step you have to do, and in this you have to make sure that whatever you are taking common, okay, that has to be 100% correct, right? If you get the value zeros as correct answer, the remaining part is very easy. Okay, now let us take the next example. Again, example number 2. Find a quadratic polynomial where the sum and product of zeros is minus 3 and 2. Okay, so here the question is asked in a reverse order. Earlier the quadratic polynomial was given to you and the question was related to the zeros. Here the zeros are given to you, correct? The sum of the zeros and the product of zeros is given to you, and you have to find the quadratic polynomial. So what you can say here first, let p of x is equal to, that is our quadratic polynomial, be ax square plus bx plus c. Here the task is very easy. Once you get the values of a, b and c, your quadratic polynomial is ready. But before that, the sum of the zeros is equal to minus 3. And what are your zeros? Zeros are alpha and beta. So we can say sum of the zeros means alpha plus beta. It is given as minus 3. And second, the product of the zeros is 2. So we can say alpha into beta is equal to 2. Now we also know that what is alpha plus beta? Alpha plus beta is minus b by a, that is equal to minus 3. And here alpha into beta is c by a, that is equal to 2. Correct? Now when you solve this, here minus minus 2 will get cancelled. So we are getting value of b upon a is equal to 3. Can I say it is 3 upon 1? And similarly here also value of c upon a will be 2 upon 1. So on directly equating, can I say the denominator is giving me same value? It means the value of a has to be 1. Value of a has to be 1. So if a is 1, the numerator automatically it will become equal. So value of b will be 3 and the value of c will be 2. So if the values of a, b and c are known to you, then what is my quadratic polynomial? Quadratic polynomial is p of x, that is ax square plus bx plus c, and where the value of a is 1, so this will become 1x square, plus value of b is 3, so this will become 3x, and plus value of c is 2. Okay, so this is one method you can say, or I can call it as method 1. Okay, now let us see one more method which can be considered as an easy method, right? Whenever the sum of the zeros is given to you and product of the zeros is given to you, we have one more standard form of a quadratic polynomial. Yes, that we have not discussed in the previous classes, but now I will tell you that any quadratic polynomial, whenever the zeros are given to you, okay, whenever the zeros are given to you, it can be expressed as x square minus of alpha plus beta x plus alpha beta. Okay, so yes, this and this both are same only. Okay, so what we are going to do here, basically we are just going to substitute the values, right? So this will become x square minus, what is alpha plus beta? Alpha plus beta is minus 3, so here it will become minus 3 into x plus alpha into beta. What is alpha into beta? Alpha into beta is 2, so this will become 2, correct, is equal to p of x. So if you solve it further, what you will get? Value of p of x is equal to x square minus of minus plus 3x, correct, and plus 2. So can I say I am getting the same answer within 2 steps? Okay, so any one method you can follow, correct. Now let us move on to the next example. Example number 3 is based on cubic polynomial, okay, and such type of example can be expected for 3 marks or maximum 4 marks. Okay, so here what is given? Verify that 3 minus 1 minus 1 by 3 are the zeros of this cubic polynomial, correct. P of x is given to us, and also we have to verify their relationship. So how many relationships are there in a cubic polynomial? There are total 3 relationships, right? So first, how we will check whether 3 or minus 1 or minus 1 by 3 are the zeros or not? It is very easy. What you will do? You will just keep the value of x as 3 first everywhere. If the answer is 0, you will say x is equal to 3 is the 0 of the polynomial, correct? Similarly, you will go for minus 1 and minus 1 by 3. So first, let us note down the polynomial p of x, that is 3x cube minus 5x square minus 11x and minus 3. Now here, when I substitute the first value of x, that is 3, what I will get? We can say p of 3, value of x will be 3. So 3 into 3 cube minus 5 into 3 square minus 11 into 3 minus 3 as it is, correct? So further on solving, 3 cube is 27, 5, 3 square will give you 9, minus 11 into 3 minus 3. Now let us multiply this. Can I say 3 into 27? This will give you 81, minus 5 nines are, this is 45, 11 3s is 33, correct? And minus 3. So if you add this together, right, 45 plus 33 plus 3, what you will get? 45 plus 33 is somewhere around 78, and 78 plus 3 is 81. So 81 minus 81, it will be how much? It will be 0 only. So therefore we can say x is equal to 3 is a 0 of p of x, correct? Now similarly we will verify the remaining two values also. The next value is p of minus 1, where the value of x is minus 1. So this will give me 3 times minus 1 cube minus 5 times minus 1 square minus 11 times minus 1 and minus 3, correct? So minus 1 cube is minus only, so this will give me minus 3. Here square is positive, so minus 5 will remain as it is. Here again the product will be positive, right? So minus 3 minus 5 minus 8, minus 8 plus 11 is plus 3, and 3 minus 3 will be 0. So once again I am saying that p of minus 1 is equal to 0, therefore x is equal to minus 1 is a 0 of p of x, correct? Now let us verify for the third value also. What is the third value given to us? Minus 1 by 3. So slowly we will solve now, since it is a fraction, correct? P of minus 1 by 3, this will give me 3 into minus 1 by 3 the whole cube minus 5 into minus 1 by 3 the whole square, correct? Then we have minus 11 into minus 1 by 3, and again we have minus 3. Now if you start solving, here you will get 3 times minus 1 cube is minus 1 only, and 3 cube 27, minus 5 times minus 1 square is plus 1, 3 square will give you 9, minus of minus plus, correct? 11 ones are 11 by 3 and minus 3 again. So if you want, you can simplify here as say 3 ones are 3, 9s are, so this will give me minus 1 by 9 plus 5 by 9, correct now? Plus 11 by 3 and minus 3. And now if you want, you can go for the LCM. The biggest number is 9, so this is minus 1 plus 5, so it will remain same because denominator is already 9. To make this 9, what you will do? You will multiply by 3, so into 3 will give me plus 33, correct? And here nothing is there, so into 9 will give me minus 27. So minus 1 plus 5 will give you 4, 4 plus here we multiplied by 3 na, 33. So a small mistake we have done, right? This was negative 5 only, so I'll just make it negative 5. Here also this is negative 5, right? So I am getting here minus 1 minus 5 is minus 6 in plus 33. What you will get? Plus 27, and 27 minus 27 will be once again 0. So 0 upon 9 will be again 0. Therefore we can say again that x is equal to minus 1 by 3 is a 0 of p of x, correct? It means here all the 3 zeros of the polynomial are correct, and therefore we can call it as alpha, beta and gamma. So alpha value will be 3, beta value will be minus 1, and gamma value will be minus 1 by 3. At the same time, if I compare this polynomial with the standard form, that is ax cube plus bx square plus cx plus d, can I see the value of a will be 3, correct? Value of b will be minus 5, because here it is plus b, here it is minus 5, as simple as that. Then value of c, what is value of c? Value of c will be minus 11, correct? and value of D, if you compare, you will get it as -3. So these are the values of A, B, C and D, and alpha, beta, gamma is also ready. So what is the last part of the question now? Verify their relationship. So let us take the first relationship now. First relationship says that alpha plus beta plus gamma should be equal to how much? It should be equal to minus b by a. So if I take the LHS, value of alpha is 3 plus value of beta is -1 plus value of gamma is -1 by 3. So what is 3 minus 1? This is 2. Plus of minus is -1 by 3, and if you take the LCM, 3 to the 6, 6 minus 1 will be 5 by 3. And now if you go for the RHS, RHS is equal to minus b by a. So minus of, what is value of b? Value of b is again -5, correct? Divided by, what is value of a? It is 3. So minus of minus will give me plus 5 by 3. So as you can see, both the values are correct. Therefore we can say LHS is equal to RHS, verified. Correct? Now let us check the remaining two relationship. I hope you can just pause the video and you can just complete this part. Okay. Now my second relationship, it says that alpha beta plus beta gamma plus alpha gamma should be equal to C by A. Now here, if you take the LHS part, correct? LHS part will be equal to alpha into beta. So alpha into beta, where are the values of alpha and beta? These are my values of alpha, beta and gamma. So 3 into -1, first will be 3 into -1 plus beta into gamma. So -1 into -1 by 3, -1 into -1 by 3, and plus alpha into gamma. So alpha is 3 and this will be -1 by 3. So 3 into -1 by 3. And now if you solve it further, what you will get? This will be -3, minus of minus plus 1 by 3, correct? And here 3 cancel, so you will get here -1. On further solving, you can see -3 minus 1 will be -4 plus 1 by 3. And if you take the LCM, this will give you -12 plus 1, and I guess it is -11 by 3. Now same time we'll consider the RHS now. What is my RHS? Value of RHS is equal to C by A. Now once again, what is C here? Value of C is -11. So -11 divided by A, value of A will be once again 3. So as you can see, again both the values are same only. Therefore LHS is equal to RHS, verified. Now let us move on to the third relationship. Third relationship says that alpha into beta into gamma should be equal to -d by A, correct? So if you take the LHS, we have alpha is 3, correct? Beta is -1 and gamma is -1 by 3. The multiplication of all 3 cancel, and minus of minus will give me +1. And now if you go for the RHS will be -d by A. So minus of, what is the value of D? D is -3 and divided by value of A is once again 3. So minus of minus is +3 by 3, that is equal to 1. So once again both are giving me the same value. So we can say LHS is equal to RHS, verified. Correct? So as far as your board examinations are considered, okay, you can expect the toughest problem on a cubic polynomial, which can be like this only, okay, not more than that. So I hope you have understood all these 3 examples. Okay, similarly you can practice few examples from your NCERT textbook. Okay, we'll meet in the next class. Bye bye.